Alright, so let's continue on with our circle properties with arcs and chords. Where we left off was our theorem: if a diameter of a circle is perpendicular to a chord, then that diameter bisects the chord and its arc. If you look at our example here in the circle at the right, I have already drawn in our diameter, and make sure that you notice that that diameter is indeed perpendicular to this chord, and I have indicated that here. So the circle has a chord of 8 centimeters in length and a radius of 5. So that means from here to here, we've got that 5. And then also, if I draw in an additional radius from here to here, then I actually have a right triangle, and I know that that distance is also 5, which I have come over to the side and sketched out that triangle. With that distance being 5, and knowing that that chord is a total of 8, if we bisect it, then each piece is 4 here and 4 here. So I'll, to the side, put my 4 for my other little triangle out to the right. So now, very simple step, you see you've got a 4 for one leg, a missing leg, and then the 5 for the hypotenuse. If you recognize your triples, you've got a 3, 4, 5 triangle. So then this length here would be 3. And then I know that if, again, this is 3 here, then the piece that's missing is 2. So find the distance between the center of the circle and the chord would be this distance right here. So my answer would simply be 2 centimeters. Alright, for our next example, we've got a circle here. We see that the radius AB is 13, and I've got the distance from A to where this is perpendicular is 5. So I'm looking for the length of EF. EF is this chord here, and you'll notice that it is bisected as indicated by the tick marks. What I've done is I've pulled out a triangle over here, and I know that I'll drop the 5 in here at the top. If I come back and I sketch in a radius, I know that that radius here is the 13. And so again, I've got a little right triangle where I know I've got a 5 and a hypotenuse of 13. So my missing leg, using our Pythagorean theorem or our triples, will be 12. If I come over here, if this one length is 12, it's congruent to this one here. So 12 and 12, the total length of EF is 24. Now let's look for CE, segment CE. If I were to connect C to E on my circle, you'll notice again I have a right triangle, and I've drawn that out up here at the top. So with that right triangle, I know that this distance, as indicated from earlier, this will be 12, which represents half of that total length EF. I know that my radius is 13, so from A to C is 13. I'm given the 5 here, so the rest of that will be 8. And now I simply have another Pythagorean theorem problem. So leg of 8, leg of 12, what is the hypotenuse? If you work out your Pythagorean theorem, then CE will be the square root of 208. And if I just round, I will get 14.4 for the length of that CE distance. So for our next theorem, and I've written that in already for you, you'll have to add that in on your copy. Our theorem states that if two minor arcs are congruent, then if and only if their corresponding chords are congruent. So let's take a look at this example too. So the measure of arc BD is 40 degrees. So the arc itself on the outside of my circle here is 40 degrees. What is the measure of arc CD? Well, I know that because I have a perpendicular diameter, that the chord BC is going to be bisected. So I have bisecting tick marks here, and so then CD would be the same as BD in measure. So 40 degrees also for our answer here. For the next example, the measure of arc BD is 170. So from B all the way around to D, I've got 170. As indicated with the two sets of tick marks, then those chords are congruent. So chord BD congruent to chord CE. Therefore, the measure of arc EC is also 170 degrees. For our next set of theorems, and again I've added this one in for you, you'll have to write it on your own paper. Our next theorem states that two chords are congruent if and only if they are equidistant from the center. So remember, equidistant means equal in distance. So if we look at example 3, I've got segment AB, chord AB, is congruent to chord CD. So let's take a look at the x value. Well, from my theorem, I'm given that those would be congruent if they're equidistant from the center. So if this segment is 6, then my x is also 6. If you look at the perpendicular from our previous theorem, I know that each piece here will be congruent. So I know that if this segment is 5, then y would have to be 5 as well. And then CD is just going to be double that 5 because I have a 5 here, in which case a 5 here, and then the same thing on the other side. So CD should be 10. For our next example, you try. ED, what is the length of ED? Well, again, they're equidistant from the center, and I know that if BC is 10, ED must also be 10. In our last few examples here, we want to match the information about the circle given in the figure with the conclusion. State that theorem that justifies your choice. So let's take a look at just the different figures before we get started. If I'm given number 4 here, where I've got AB congruent to BC, I should know that the arcs would be congruent as well. So AB arc congruent to BC arc. So look at your choices here, and I find that that is C. So this one would be C, as stated from one of our earlier theorems. For number 5, if I'm given my diameter perpendicular to a chord, then I know that it bisects that chord. So now I have where AC is congruent to BC, each segment here. So looking at my answer choices, I find that that is choice A. For number 6, I've got my diameter perpendicular to a chord, which are equidistant. And again, I'm working with the diameter, so looking at my answer choices, I know that CB is a diameter. Number 6 goes with choice D. And for my last one, I see that I have some segments marked congruent here, which are equidistant from the center, in which case that would mean AC congruent to AB. So this is answer choice B here. Please feel free to watch this video again to make sure that you understand all of these different circle properties. There's a lot in circles that we do need to cover. I will see you in class. Check Edmodo for the next update.